A crater on Mars became one of the most scientifically valuable holes in the solar system, not because of what fell into it, but because of what it exposed on its walls, and because a rover spent nearly 2 years circling it before anyone dared go inside. Victoria Crater is not the largest or the deepest on Mars, but it is the most extensively studied impact crater ever examined by a surface vehicle on another planet, and the images HiRISE produced from orbit transformed it from a geological feature into a three-dimensional record of Mars's ancient past. Victoria is roughly 800 meters across and about 70 meters deep, located in the Meridiani Planum region of Mars, the same flat, sulfate-rich terrain where NASA's Opportunity rover landed in January 2004. The crater formed through impact, but what made it scientifically exceptional was its exposure of stratified rock layers in its walls, horizontal beds of sedimentary material that recorded environmental conditions from millions of years of Martian history, readable almost like pages in a book. Opportunity reached the rim of Victoria Crater in September 2006, 2.5 years after landing, having already exceeded its planned 90-day mission. What the rover found at the rim was a series of scalloped bays and steep promontories, alternating indentations and outcroppings shaped by differential erosion, with exposed rock layers visible in the walls dropping 70 meters to the crater floor. The HiRISE camera, operating from Mars Reconnaissance Orbiter at roughly 300 kilometers altitude, imaged Victoria during Opportunity's entire period at the crater, from initial arrival in 2006 through the rover's entry inside and eventual departure in 2008. These images achieved resolution down to approximately 25 centimeters per pixel, revealing individual boulders on the crater floor, the detailed scalloped geometry of the rim, fresh erosion patterns on the walls, and, critically, the Opportunity rover itself, clearly visible as a small bright dot moving methodically around the rim and later descending inside. That combination, ground truth from Opportunity plus high-resolution orbital context from HiRISE, made Victoria the best-studied impact crater on any planet other than Earth. What did the walls reveal? The exposed layers inside Victoria Crater show alternating dark and lighter bands, fine-grained and coarser beds, interpreted as ancient Aeolian deposits, meaning material laid down by wind in a dune environment. But the layers also contain hematite spherules, the blueberries first discovered at Eagle Crater in 2004, embedded in the rock at consistent heights, indicating they formed in groundwater-saturated rock over extended periods. The consistency of these layers across different parts of the crater wall confirmed that the ancient environment was widespread and persistent, not a localized event. Rock samples taken by Opportunity's tools inside Victoria showed elevated sulfate mineral content, the same evidence from the broader Meridiani region that the area was once extensively soaked in acidic groundwater. The interior of Victoria offered deeper access to older rock, which had been buried deeper before the impact exposed it. The decision to enter the crater was not made lightly. The walls are steep. If the rover descended and became stuck, it could not be retrieved. But the scientific value of accessing rock layers below what the rover had already examined was judged worth the risk. Opportunity entered through a bay called Duck Bay in September 2008, descending carefully down the 20-degree slope and spending several months examining exposed bedrock before successfully climbing back out in August 2008. Today, the HiRISE Image Archive contains a complete visual record of every stage of that investigation, before, during, and after, at resolution that was previously impossible from orbit. The images show how the crater's rim changed slightly between observations, how the rover's wheel tracks remained visible in the regolith months after Opportunity had moved on, and how the lighting angle at different times of the Martian day revealed different textures in the rock layers. Victoria is not just a hole in the ground. It is a scientific cross-section of ancient Mars, a demonstration of what surface and orbital teamwork can accomplish, and the most complete geological investigation of an impact crater ever conducted beyond Earth. Follow for more on the discoveries that came from one rover's extraordinary life on Mars. And tell me, Opportunity spent nearly 2 years studying Victoria Crater at enormous risk. If you were making the decision, Would you have sent the rover inside, or kept it safely on the rim?